Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face Trending List, published on November 25th, 2025, about 2 days ago. This paper turns a powerful video generation model into a unified many-to-many image generator, combining video-style temporal coherence with the wild diversity of standalone images to create highly dynamic, yet consistent, image sequences. The paper is titled iMontage, Unified, Versatile, Highly Dynamic Many-to-Many Image Generation. And as we will see later, the approach opens up some very exciting possibilities for flexible image editing and storytelling. Also, the authors shared a GitHub repo for iMontage. There you'll find the full Python implementation, environment setup, and inference scripts, plus instructions for downloading the pre-trained weights. It walks you through running their many-to-many image generation examples, editing the JSON prompts, and creating your own multi-image, multitask montage outputs. Figure 1 gives a visual tour of what iMontage can do, showing that the same model handles many-to-many, many-to-one, and one-to-one image generation. Many-to-many means several input images produce a whole sequence of related outputs, like storyboards. Many-to-one means multiple references fuse into a single stylized subject. One-to-one covers classic image editing, where a single input becomes a single but transformed output. The dotted line boxes mark which images serve as inputs in each collage. Figure 2 explains how iMontage actually processes text and images to generate a whole set of outputs. The central pipeline shows text prompts and input images being encoded, turned into tokens, and then passed together through the video-style backbone, so the model can tie story instructions and visual references into consistent target images. On the right, the dual-stream and single-stream blocks illustrate how text tokens stay fixed length, while image and noise tokens vary in number. At the bottom, the marginal ROPE diagram shows special temporal indexing that splits input and output image slots, which helps the model treat them like video frames, while still allowing flexible many-to-many image generation. Figure 3 explains how the training data covers all the complex behaviors this model needs to learn. The left side stacks 4 data sources, from open web images to carefully distilled internal sets, so the model sees both raw diversity and cleaner supervision. The top panels focus on single-turn and multi-turn editing plus style and reference-based transfers, which teach consistent identities and styles. The bottom panels add multi-view generation, meaning the same object is seen from different camera angles, and storyboard generation, where text-linked image sequences teach long-range story coherence. Table 1 makes the performance story concrete, showing how different editing models score on motion change, overall edit quality, and a separate image editing benchmark. The whole table compares closed-source systems like Gemini 2.5 and GPT-4o with many open-source baselines. Motion change here means how well an edit can introduce or modify actions between frames while staying semantically consistent. Across both motion change and overall edit columns, iMontage stands at or near the top among open-source models, which signals strong temporal control. On the IMG edit scores, it also matches or beats most competitors, so the model is not just dynamic, but also a solid general editor. Table 2 shows how different models perform on the OmniContext benchmark, which scores how well generated images follow instructions about characters and objects across single images, multiple images, and full scenes. OmniContext is a holistic test that checks whether models keep identities and requested items consistent while varying layouts. The table groups systems into closed source and open source categories. Among the open-source models, iMontage achieves the best average score, so it offers the strongest all-around control over characters, objects, and complex scenes in this evaluation. Table 4 reports how humans rate different models at generating storyboards, meaning sequences of panels that tell a visual story. The table shows that iMontage scores highest for following instructions and keeping character identity stable, which are crucial for coherent narratives. It also lists temporal consistency, meaning how smoothly the story flows across panels, and overall quality. Across all 4 metrics, iMontage clearly outperforms story diffusion, UNO with UMO, and OmniGen 2 with UMO. Alright, 2 big takeaways stand out. iMontage shows that video-style motion priors can power a single, unified model for many-to-many image editing, and it delivers state-of-the-art open-source control over characters and stories. This could really reshape creative tools. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.